Hello, welcome back to the lecture on basic principles of organic chemistry and some methodologies that are used in organic chemistry. In the previous lecture, we were discussing the method of estimation of carbon and hydrogen in order to determine the percentage of carbon and hydrogen in an organic molecule. Now, organic molecules can also contain nitrogen, halogen, phosphorus, sulphur and so on. So, let us have a look at the methodology used for the estimation of nitrogen first in a quantitative manner. There are two methodologies that are used for the estimation of nitrogen. The first methodology is known as Dumos method. In this particular methodology, the organic compound containing nitrogen is treated with copper oxide and copper. In the process of heating the organic compound, let us say the organic compound has this kind of a molecular formula. When it is heated over a surface of copper oxide and copper metal under a stream of carbon dioxide, the carbon present in the organic compound is converted into carbon dioxide completely, and the hydrogen that is present in the organic compound is converted into water, and the nitrogen is converted into N2 gas. So, the amount of nitrogen that is liberated during the process of this heating is measured using a nitrometer. A nitrometer, it is a device which is used for measuring the volume of the nitrogen that is evolved during the course of this particular reaction, and from the estimation we will essentially get, for example, volume of nitrogen liberated from the organic compound. From the volume of nitrogen liberated from the organic compound, one can directly find out the percentage of nitrogen that is present in the organic compound. Let us take an example. Let us say m grams of an organic compound is subjected to Dumos method of estimation. And if the volume of nitrogen collected is V1, V1 milliliters at a temperature of T1 and a vapor pressure of P1 for example. Now, this is the laboratory temperature at which the gas is collected, and this is the pressure at which the gas is collected. This pressure need not be atmospheric pressure, because there will be some water vapor pressure because of the fact that the nitrogen is collected over water. So, one need to correct the vapor pressure for the actual vapor pressure of nitrogen by subtracting the vapor pressure of water vapor at that particular temperature. Then one uses the equation P1 V1 by T1 is equal to P2 V2 by T2 in order to find out the volume of nitrogen gas that is collected under standard temperature and pressure. In other words, at 273 Kelvin temperature and 760 millimeter of mercury atmosphere, that is 1 atmosphere of the pressure of nitrogen. So, let us say for example, this is the P1, which is the pressure at which the nitrogen is collected, V1 is the volume of the nitrogen that is collected, and T1 is the temperature at which this is collected. We want to find out V2 now. So, V2 will be equal to P1 V1 multiplied by 273 Kelvin, which is the standard temperature condition, divided by T1, that is the temperature at which the experiment is carried out or the nitrogen is collected, multiplied by P2. So, if you solve this, then you can get the volume of nitrogen at standard temperature and pressure or normal temperature and pressure. Now, once you have the volume of nitrogen that is collected at a standard temperature and pressure, that is 273 Kelvin and 1 atmosphere, this is 760 millimeter of mercury, the standard condition. Then one can use the expression, if you have 22,400 milliliters of nitrogen at STP, this would correspond to 28 grams of nitrogen. This is 1 mole of nitrogen essentially contains 22.4 liters or 22,400 milliliters of nitrogen. So, what would be the amount of nitrogen for V2, sorry, the V1 which is collected, the V2 which is at standard temperature and pressure, which we calculated from this expression, what would be the weight of nitrogen that is present. So, if it is 22,400 ml, it corresponds to 28 grams. So, for V2, how much will be the weight of nitrogen corresponding to V2 ml of nitrogen. If 22.4 liter or 22,400 milliliters of nitrogen weighs 28 grams of nitrogen, that is 1 mole of nitrogen, then how much will be the V2 ml of nitrogen corresponding weight of nitrogen, that is calculated by this expression here. Now, this is coming from m grams of the compound. So, for 100 grams how much will be, this would be the percentage of nitrogen that is present in the organic compound. So, the basic principle is the organic compound is converted, the nitrogen present in the organic compound is converted into gaseous N2, and the N2 is collected in a nitrometer, and the volume of N2 collected is at the laboratory temperature and pressure, and that is converted using this expression P1 V1 by T1 equal to P2 V2 by T2 into standard conditions, namely 1 atmospheric pressure, that is 760 millimeters of mercury and 273 Kelvin of temperature. Once you convert that, then we have this expression that 22,400 milliliters of nitrogen at standard temperature and pressure condition corresponds to 1 mole of nitrogen or 1 molecular weight of nitrogen, that is 28 grams of nitrogen. So, if the weight of nitrogen has to be found out for the V2, which is the volume that is being collected at STP, this would be the expression, that is for 22,400 milliliters it is 28 grams. Therefore, for V2 volume of the nitrogen collected STP, how many grams of it. So, this will give the weight of nitrogen that is being collected in the nitrometer, that is coming from m grams of the substance. So, for 100 grams of substance, what will be the weight of nitrogen? That will correspond to essentially this particular expression will give you the percentage volume of percentage weight of the nitrogen present in the organic substance. Let us illustrate this with an example. Let us say, for example, 0.3 grams of an organic substance on Dumos method gives 50 ml of nitrogen is evolved during the estimation of nitrogen. So, from 0.3 grams of organic substance, 50 milliliters of nitrogen is evolved at 300 Kelvin and 715 millimeter of mercury, that is the pressure at which the nitrogen is collected, for example. Now, water vapor pressure at 300 Kelvin is equal to 15 millimeters of mercury. So, you need to subtract the actual pressure P1 will be equal to then 715 minus 15, which is due to the water vapor pressure. So, actually it is 700 millimeters of mercury is the actual pressure due to the nitrogen. So, if it is P1 if V2 is equal to P1 V1 by T1, this expression that we are having here multiplied by T2 by P2. If you substitute the values here, P1 will be equal to 700 and volume of nitrogen that is collected is 50 milliliters, and temperature T2 will be 273 Kelvin, which is the standard temperature. T1 is given as 300 Kelvin and P2 corresponds to 760 millimeters of mercury, which would be 1 atmospheric pressure. If you solve this, it amounts to 41.9 ml of nitrogen is collected at STP. Therefore, weight of nitrogen is equal to, for 22,400 milliliters, it corresponds to 28 grams. Therefore, for 41.9 milliliters, how much it corresponds to. So, one can solve this particular arithmetic problem. The percentage weight of nitrogen present in the molecule, nitrogen present in the entire mass that is taken, the mass taken is 0.3 grams. So, 28 multiplied by 41.9 divided by 22,400. This is from 0.3 grams of the substance. Therefore, for 100 grams of the substance, how much will be the weight of nitrogen? That would correspond to the percentage of nitrogen in the organic compound. If you solve this particular simple arithmetics, it turns out 17.46 percentage of nitrogen is present in the organic molecule. So, this illustrative example, I hope, helps you to understand the basic principle behind the methodology that is used for the estimation using the Dumos method of analysis of So, I hope the basic principle is clear. The nitrogen present in the organic compound is completely converted into N2 nitrogen gas, and the volume of gas measured at a particular temperature and pressure is converted into standard temperature and pressure. And from the Avogadro volume, for example, 22,400 milliliters of nitrogen, which corresponds to 1 mole of mole weight of nitrogen. Nitrogen has an atomic weight of 14. So, N2 would correspond to 14 plus 14, which is 28 grams of. So, this volume of nitrogen we know is 28 grams. So, the volume that is collected, how many grams, is what is calculated using this expression here, and that comes from the mass that is taken of the organic substance. So, for 100 grams of the organic substance, what would be the, so this would be corresponding to the percentage of nitrogen that is present in the organic compound. So, this is the methodology that is used conventionally for estimating nitrogen. There is one other methodology which is known as Geldale's method of estimation. We will discuss the Geldale's method of estimation next. The second methodology is Geldale's method of estimation of nitrogen in an organic compound. In this method, the organic compound is strongly heated with sulfuric acid in the presence of copper sulphate as a catalyst, and in the process the nitrogen present in the organic compound gets converted into ammonia, and in the presence of sulfuric acid, of course, the ammonia will react with sulfuric acid and it will form ammonium sulphate as the inorganic form of the nitrogen that is present in the organic compound. So, all of the nitrogen that is present in the organic compound is converted into ammonium sulphate. Now, the ammonium sulphate, once it is formed, it will be present along with the excess sulfuric acid, because you take excess of sulfuric acid and essentially boil it in excess sulfuric acid, strongly heat it in excess sulfuric acid, wherein the nitrogen of the organic compound gets converted into ammonium sulphate. Now, this is neutralized with sodium hydroxide, it is boiled with sodium hydroxide. So, what happens when you take an ammonium salt and boil it with sodium hydroxide? Initially, the sodium hydroxide will neutralize the excess of sulfuric acid into sodium sulphate and water, and then the excess sodium hydroxide will react with the ammonium sulphate to produce ammonia gas. This ammonia gas that is formed in the reaction is adsorbed on excess of acid. .1 molar solution of hydrochloric acid is used in order to absorb the ammonia, upon which the ammonia forms the ammonium chloride. Since the known volume of more than what is necessary for neutralizing the required amount of ammonia is taken, there will be excess of hydrochloric acid. This is essentially a titrimetric method. Ammonium chloride is formed plus excess HCl will be present here. This is once again neutralized with known concentration of sodium hydroxide. So, essentially what you are doing is a back titration methodology in order to estimate the amount of substance that is being converted into ammonia in an organic molecule. This can be explained as follows. Using an illustrative example, one can .257 grams of an organic substance was treated with sulfuric acid, copper sulphate. In other words, the Geldale reaction was carried out, and liberated ammonia on treatment with sodium hydroxide is neutralized, absorbed on (50 ml) of molar by 10 concentration of HCl. Now, the excess acid required (23.2 ml) of molar by 10 concentration sodium hydroxide. So, this is the given data. What is done is the compound is treated with sulfuric acid and copper sulfate, thereby ammonium sulfate is formed. The ammonium sulfate is liberating the ammonia on treatment with sodium hydroxide. The liberated ammonia is absorbed with 50 ml of molar by 10 of concentrated hydrochloric acid. So, this is the concentration. This would correspond to 0.1 molar of HCl. Similarly, this would correspond to 0.1 molar of sodium hydroxide. So, this is a large excess of HCl is what is taken. So, the excess acid required 23.2 ml of sodium hydroxide for neutralization. So, from this calculate percentage of nitrogen in the organic compound. This is a question that one needs to be addressed. Now, volume of m by 10 sodium hydroxide needed for the neutralization is 23.2 milliliter. This would essentially correspond to 23.2 milliliters of molar by 10 concentration of HCl that was neutralized. Therefore, unused HCl is equal to, or the excess unused HCl is equal to 23.2 ml of HCl of m by 10 molarity. So, the HCl used for absorbing the ammonia absorption will be equal to, originally 50 milliliters were taken, 23.2 remained unreacted or excess. So, that would correspond to essentially 26.8 ml of m by 10 HCl. So, all we need to do is convert that into mass. That is easily done. So, the 26.8 ml of m by 10 HCl will be equal to, in terms of the neutralization reaction, 26.8 ml of m by 10 ammonia solution, which was originally liberated by the Geldale method of liberating the ammonia. We know that 1000 ml of 1 molar ammonia corresponds to 14 grams of ammonia, 14 grams of nitrogen. In other words, if you take 1 mole of ammonia, 100 ml 1 molar solution, there will be 1 mole of ammonia. In 1 mole of ammonia, essentially you will have 14 grams of ammonia. From the molecular formula NH3, the amount of nitrogen present is 14 grams. So, what we are having here is n by 10 of ammonia solution. So, 1000 ml of m by 10 ammonia would correspond to 1.4 grams of nitrogen. So, the weight of nitrogen will be from the ammonia that is liberated would correspond to, for 1000 milliliters it is 1.4 grams, from 26.8 milliliters how many grams of nitrogen is present here. So, if you want the percentage of nitrogen in the organic compound, you have to take the weight of the organic compound that is taken, weight of the organic compound that is taken is 0.257 grams of the organic compound. So, 0.275 grams of organic compound will contain this much of nitrogen. So, 100 grams will contain how much of nitrogen? If you solve this numbers, it will correspond to 14.6% of nitrogen present in the organic compound. So, let me go through this once again. 0.257 grams of organic compound is treated with sulfuric acid and copper sulfate in a Geldale reaction, that is this methodology of estimation. It liberates ammonia by first it forms ammonium sulfate. The ammonium sulfate liberates ammonia on treatment with sodium hydroxide. The liberated ammonia is absorbed on excess of sulfuric acid. How much of excess of sulfuric acid? 50 milliliters of molar by 10 concentration of hydrochloric acid. So, the excess acid required this much of the sodium hydroxide for neutralization. So, you take 50 milliliters of m by 10 HCl, some of it is consumed by the ammonia that is liberated, the remaining portion is neutralized with sodium hydroxide essentially to estimate the amount of excess acid that is being present. So, the unused acid would essentially correspond to the 23.2 ml of hydrochloric acid, because the molarities are same for sodium hydroxide. It is a monobasic acid and a monoacidic base. They will neutralize, equal volumes will neutralize completely of each other. So, the volume of sodium hydroxide essentially corresponds to the volume of hydrochloric acid, because both of them are equimolar solution, 0.1 molar solution. The unused hydrochloric acid essentially would correspond to 23.2. So, therefore, the used hydrochloric acid, the hydrochloric acid that is used for absorption of ammonia will be total hydrochloric acid taken minus the excess hydrochloric acid that was present after ammonia absorption, which would be 26.8 milliliters. This 26.8 milliliters of hydrochloric acid essentially corresponds to 26.8 milliliters of ammonia of equal molarity, that is 0.1 molar solution. Therefore, for 1000 milliliters of 1 molar ammonia contains 14 grams. This is essentially corresponding to 1 mole of ammonia dissolved in 1000 milliliters of water. So, that has 14 grams. From the molecular formula you can tell it is 14 grams for 1 mole of the ammonia that is dissolved. So, for the m by 10 concentration it will be about 1.4 grams, 1/10 of the weight will be there. So, the weight of nitrogen essentially corresponds to, for 1000 milliliters it is about 1.4, therefore, for 26.8 milliliters of ammonia how much is the weight? Percentage weight for 0.257 grams of the substance that is taken, this will be the nitrogen that is present. For 100 grams how much will be the present nitrogen? That is 14.6 percentage of nitrogen that is present in the organic compound. Let us illustrate this one more with one more example also, just to familiarize yourself with the problem of estimation of nitrogen using the Geldale method. Essentially, it is a titrimetric method. You do back titration of an excess acid that is originally taken for absorbing the ammonia. and the unused amount of acid is subtracted from the original amount of acid that is taken, and that gives you the amount of acid that is used for ammonia absorption, so on. Let me clean up this board completely so that we can use up the .35 grams of an organic substance was geldalized. Geldalized means essentially treated with sulfuric acid and copper sulfate, and the ammonia obtained was passed into 100 ml of M/10 sulfuric acid. The excess acid required (154 ml) of M/10 sodium hydroxide. Calculate the percentage of nitrogen in the system. In the organic compound. This is the problem. Now you start from here, 154 ml of sodium hydroxide, which is needed for removing the excess acid. This would essentially correspond to, if you take the sodium hydroxide plus H2SO4, you need two equivalents of sodium hydroxide because this is a dibasic acid. Na2SO4 plus 2H2O is the formula. So, if you are taking 154 milliliters of sodium hydroxide of M/10 concentration, this would correspond to half the amount of the sulfuric acid that is needed. So, this will correspond to 154 divided by 2 milliliters of M/10 sulfuric acid, which is 77 milliliters of sulfuric acid. Originally, the amount of sulfuric acid taken is 100 ml. Therefore, sulfuric acid used for ammonia absorption will be is equal to 100 minus 77, which is equal to 23 milliliters of M/10 sulfuric acid. So, 23 milliliters of sulfuric acid is actually used for the absorption of ammonia in this particular case. Now, ammonia is also the form of ammonium hydroxide. You need two equivalents of ammonium hydroxide to neutralize this. So, the 23 ml of M/10 sulfuric acid is actually equal to 46 milliliters of ammonia. Of m by 10 concentration. The same concentration has to be maintained here. So, if 1000 milliliters of ammonia corresponds to 14 grams of 1000 milliliters of 1 molar ammonia corresponds to 14 grams of nitrogen. 1000 milliliters of m by 10 ammonia would contain 1.4 grams of nitrogen. Therefore, weight of nitrogen is equal to 1.4 grams in 1000 milliliters of m by 10. So, how much will be present in the 46 milliliters of the solution that is used for the neutralization purposes? The percentage nitrogen will be equal to 1.4 times 46 divided by 1000. This is present in 0.35 grams of the organic compound. Therefore, for 100 grams of organic compound, how much will it be? If we solve all these things, this would essentially correspond to 18.4% of nitrogen being present in the organic compound. So, this is a second example of the Geldale's method of estimation of organic compound using the sulfuric acid and copper sulfate method. So, essentially if you are familiar with the titrimetric method, you will not have any problem solving this kind of problems. You will not have any difficulty in solving this kind of problems during the examination. Basic principle is simple. Ammonia is liberated, it is absorbed onto excess sulfuric acid or excess hydrochloric acid depending upon the acid that is taken. The excess sulfuric acid is neutralized with sodium hydroxide. From the volume of sodium hydroxide, we know how much of sulfuric acid is present in the system after the ammonia absorption. So, the difference will give you the actual amount of sulfuric acid that is used for the ammonia absorption or ammonia neutralization. That will be twice the volume of the ammonia because it is a dibasic acid. You need 2 equivalents of ammonium hydroxide. Once you have the exact volume of ammonia in terms of the concentration, you convert it into weight because we know 1 molar solution of 1000 ml contains 1 mole of ammonia, which is 14 grams of nitrogen. In 1 mole of ammonia, essentially you have 14 grams of nitrogen. In other words, 17 grams of ammonia, which is corresponding to 1 molar solution of 1000 ml, contains 14 grams of nitrogen. So, for 1/10 of the molar solution, it will be 1/10 of the weight, and that is present in the given organic compound. So, percentage weight you need to calculate by multiplying by 100, which gives you the percentage nitrogen present in the organic compound. So, I hope these two examples, arithmetic examples, illustrate the use of the Geldale's method for the nitrogen estimation. The next estimation is halide estimation. Estimation of halogen is done by Carious method. Carious spelling is Carius. Carious method of estimation of halogen. When we say estimation of halogen, we are primarily talking about the estimation of chlorine, bromine and iodine only, not necessarily fluorine. This is easily done by taking a sealed tube or a thick walled tube in which the organic substance is taken, concentrated nitric acid is added along with silver nitrate. So, silver nitrate, concentrated nitric acid plus the substance is taken, and this is fused at one end. In other words, it is completely closed, and this is tube is what is known as the Carious tube. The methodology is known as the Carious methodology of estimation of halogen. The organic compound, let us say, contains some X halogen Z times. The X is equal to chlorine or bromine. The number of chlorine and bromine present are corresponding to Z in this particular case. On treatment with nitric acid and silver nitrate, HX is formed during the course of the decomposition of the organic compound. The HS reacts with the silver nitrate, producing silver X, which is precipitated. So, at the end of the reaction, you will see a precipitate in the Carious tube. That precipitate is filtered, washed thoroughly and dried. So, the dry weight of silver X formed is estimated or measured. Now, we know in the case of silver salts, what is the amount of halogen that is being present. If we take silver chloride molecular weight corresponds to 143.5, and this contains 35.5 grams of chlorine. In other words, 1 mole of silver chloride contains 35.5 grams of chlorine. So, if X is the weight of X grams of silver chloride obtained in the Carious method, how much will it be? So, 35.5 grams are from 143.5 grams. Therefore, for X grams, how much of this? This will be from a known amount of the mass of the organic compound, and for 100 grams, how much will it be? This will be giving the percentage of chlorine in the organic compound. We will illustrate this with a simple arithmetical problem. Let us say, for example, 0.15 gram of an organic substance gave 0.12 grams of silver bromide when it is treated with nitric acid and silver nitrate using Carious method. What is the percentage of bromine in the organic compound is the question that one needs to be addressed. Silver bromide molecular weight corresponds to silver is 108 plus bromine is 81. So, 180 bromine is 80. So, it corresponds to 188 grams is the per mole of the silver bromide. 188 grams per mole of silver bromide is equal to 80 grams of bromine. Therefore, for 0.15 grams of the silver bromide, how much is the sorry 0.12 grams of the this would be equal to 80 divided by 188 multiplied by 0.12. So, this is the amount of bromine that is present in the compound. If you want the percentage of bromine in the organic compound, this would be equal to 80 multiplied by 0.12 divided by 188. This is present coming from 0.15 grams of the organic compound. For 100 grams of the organic compound, how much will it be? It turns out it is about 34.04% if you work out this example here. So, that much amount of the bromine is present in the organic compound. So, one can do either bromine estimation or chlorine estimation. The point is 143.5 grams of silver chloride, which is 1 mole of silver chloride contains 35.5 grams of chlorine, which is the atomic weight of chlorine. So, if you get a precipitate of x grams of silver chloride, how much will be the compound, how much amount of the chloride will be present is given by this expression. That is coming from certain weight of the organic compound. So, for 100 grams of organic compound, how much will be the chlorine that is present in terms of the percentage weight of the chlorine in the organic compound. Now, let us move on to sulphur estimation. Sulphur is estimated in the form of sulphate. So, the organic compound has to be containing the sulphur has to be oxidized. So, a sulphur compound is treated with concentrated nitric acid and sodium peroxide. So, concentrated nitric acid and sodium peroxide essentially converts the compound into sodium sulphate, to which barium chloride is added. A solution of barium chloride is added, which forms barium sulphate, which is an insoluble precipitate. So, the basic principle chemistry is that the compound, let us say for example, a thiol is taken, it is completely oxidized to the sulphate. To convert the sulphur is converted into an inorganic sulphate, and the inorganic sulphate essentially is converted into barium sulphate, which is an insoluble compound. In case of barium sulphate, the molecular weight is 177 for barium, 32 for sulphur and 64 for oxygen. Totally it is 233 grams. 233 grams of barium sulphate contains 32 grams of sulphur. So, the weight of barium sulphate you get from here, let us say it is x grams of barium sulphate would contain 32 divided by 233 multiplied by x grams. This is coming from a known weight of the organic compound M. So, the percentage of sulphur would be equal to 32 multiplied by x divided by 233 from known mass M. So, for 100 grams how much will it be? So, that will be the percentage of sulphur present in the organic compound. One example we will solve, and then we will conclude this lecture with a summary. Point 157 grams of an organic compound gave 0.4813 grams of barium sulphate using the barium sulphate estimation method or sulphur estimation method. What is the percentage of sulphur in the organic compound? So, you use the expression 233 grams of barium sulphate is equal to 32 grams of sulphur. This much amount of barium sulphate, how much will it be? (32) divided by 233 multiplied by 0.4813 grams. 0.157 grams of organic substance gave this many grams of sulphur. (100 grams of organic substance will give 32 multiplied by 0.4813 divided by 233 multiplied by 0.157 multiplied by 100. If you work this out, it corresponds to about 42.10% of sulphur being present in the organic compound. So, overall what we have seen in this particular lecture is the methodology for the estimation of nitrogen in the organic compound using Dumos methodology, where nitrogen is evolved from the organic compound and the measured nitrogen is essentially converted into the weight and percentage weight. In the Geldale method, the nitrogen present in the organic compound is converted into ammonia, which is absorbed in excess acid, and using a titrimetric estimation, we estimate the ammonia that is liberated. From the ammonia that is liberated, we calculate the weight of the nitrogen present in the organic compound and hence the percentage weight of the nitrogen present in the organic compound. For the halogen estimation, we have Carious methodology, where the halogen is converted into an inorganic halide and precipitated using silver nitrate. Using silver nitrate, you get the silver halide precipitate. From the silver halide precipitate, weight of the silver halide precipitate, one can estimate the amount of halogen that is present. Couple of representative examples were given. Similarly, for sulphur, it is estimation of sulphur using the conversion of the sulphur compound into sodium sulphate and finally to barium sulphate, which is a precipitate. From the amount of barium sulphate precipitate that is obtained, one can estimate the amount of sulphur that is present in the organic compound. With this, we conclude this lecture. Thank you very much for your kind attention.